Okay. Good morning. My name is Renzo Carpio. I am a student at the Syracuse University. I'm going to do the presentation regarding the face recognition and verification application. This was done for the CIS663 Biometrics class. So let me go over what I did. What I tried to do with this application is to develop a face recognition and a verification application using the Microsoft Cognitive Services. More specifically, the facial recognition feature. Then I'm gonna do an analysis of the application to test the Azure efficiency using the SOF dataset. Now, we touch a lot of parts for the facial recognition process in class. I've tried to implement and recreate those processes through this application, okay? The technologies that I've used, first is the Viola-Jones algorithm. I've used the Microsoft Cognitive Services. I use Microsoft Azure, and I've used the SOF dataset, okay? The application is live. The application can be accessed and is available to everybody through this URL. And this is a screenshot of the application. The application was deployed using web app in Azure. And the first part that we're gonna do is the face detection feature. So as I was explaining before, right? So we need to detect a face. And for that, Microsoft Cognitive Services is using the Viola-Jones algorithm. Now, that's the core. They have improved, they have done some more research, and this, is way better. It's an improved algorithm, and based on different measures, it's been improved a lot. But the core is the same, right? So for the detection, we're gonna provide an image, and then we're gonna see if we can detect one or more faces on that image, right? That's the process that we need to do. So what we need to do? First, based on the research that I did for the cognitive service and for the facial API, the first step is to convert the image to a grayscale. Then an integral image is computed and for a grayscale image, right? Then the hard features are extracted from all the possible locations, and then once that the hard features are extracted, they are presented to the cascading classifiers. So that's the whole process of the detection phase, right? And for that, as I mentioned before, and just to give an overview of what we saw in class, for the Viola and Jones detection method, it locates the general features in an image, let's say, for example, eyes, nose, lips, and those do not match these features to specific pairs, right? So that's pretty much what the Viola-Jones algorithm does, that detection of the face, right? So that's the first step that we need to do. So it's a type of algorithm. When we use hard features, then we use a combination of these features through rectangular sections. As we did in homework 2, we had this exercise where we needed to move, let's say, for example, this square through all the pixels in an image, right? And we will move it like sideways, then up and from up down, and we will have a specific values, right? Or key attributes that we needed to get, right? So for that, one of the most important part is that, and one of the things that we need to mention is that the Viola-Jones framework is one of the fastest and most accurate face detection algorithm, right? And cascading is one of the key parts of this process, right? Because all the negative areas are ruled out quickly, while the possible faces in the detection process are tested, right? While we detect the hard features, then we have the sums and difference between the rectangular parts of a picture through the process that I was explaining before and through what we did in homework too. Then these are sent to the classifier cascade, and then they are sent for further improvements. After the first iteration, the face identification has identified some possible faces, and these hard features are classified, and the ones that are not detected are discarded, and only the ones that contain a face in the picture go to the next step of the pipeline, right? So that's really important. Now, in this specific case, for the detection feature, we are using the Microsoft Cognitive Service. Now, we have 27 predefined landmark points returned by the Face API. All the ones that we see here. This is a picture that I extracted from the Microsoft site. And it also gives us the ability to extract attributes like the gender, age, emotions based on these landmarks, right? So if it is a laugh, then we can maybe use the upper lip, top, bottom, and then the mouth, right, under lip, top, or under lip, bottom, to see which are the emotions of that specific person, right? So let's go to the application itself. So the first part that I wanted to recreate was the face detection that we saw in class. So as I mentioned, this is available here. I'm gonna copy and paste this URL, go to the site, and as I hit this, it's gonna take me here, okay? Now, I have to mention also one key part. I told you that I'm using Azure, right? So if I go to Azure, I created a cognitive service instance. Well, let me change that let me change it to my personal account from my work account. And I have created an instance of the cognitive service. In more details, this is called a cognitive service instance. And I've named this service RC Face Emotion. Okay, that is the backbone for the application that we are using. So we have two main parts: the cognitive service, the Azure cognitive instance that we have created. I have configured and I went through all the steps to set it up, put it up and running, collecting all the information and configuring the service itself. I'm not going to go through that process here because it's going to take all the presentation. But just to let you know that this is one of the key important parts of the application. So far, I've used almost 2,000 calls of the 30,000 that I have. Those 2,000 calls has been for testing purposes. This is the instance that I'm using, okay? The application has been also deployed into Azure. That's why it's available online. And this is the application that I have deployed in for this research application into Azure. So if I go to this site now, I'm gonna get to the home page, and in the home page I have preloaded the image of Bill Gates. I can change this to any URL of an image, and it will analyze that image. But let me go over this. If I click Analyze, then it's gonna detect the face, and this service returns just raw information, right? So I have to develop and create all the logic behind what it was returned to get to this point, right? It's important because we just get raw information. Now I need to extract all this information and map it to what I wanted to do in this application, which is face detection, the first part. So for Bill Gates, right, we put the URL, we loaded the image, we click Analyze, and it returned the response. So we have a 3D view and a raw view that I have created for us to be easier to see and I told what attributes I need. I need these attributes. So for the face attributes, we can see that the person is smiling, maybe because he's doing a lot of philanthropy work in the world. Maybe he's very happy because of that. He has reading glasses, his emotion, he's happy. And we can see that he's 58 and he's a male. As I mentioned, we can do that for a lot of people. I was searching that before, so I'm gonna copy image. I'm gonna put the URL, I'm gonna click analyze, and the face was detected, right? The face attributes, I'm gonna see it's a female, gender, age 58, her emotion, happiness. Oh, it's hard to see Margaret Thatcher happy, but saying that he's happy. And we're also gonna check the makeup. It's true, line up. Lipsticks also have some makeup. And also I was searching for some information before. So let me copy the image address to have another example of that. I'm gonna click analyze, and we have the same thing. Smile, age 37, which is pretty close, female, no glasses, and we also have hair, right? Attributes. I created these 5 just to make sure that we fall in any of those buckets. For blonde, is 1%, yes, 100%, so she's blonde. So that's in regards of the face detection part, right? So that's one of the features that we have developed for this application. The second application, the second part for the application is the face verification feature. The face verification feature verifies whether 2 faces belong to the same person. And 2 attributes are returned: confidence and identical. Confidence is gonna tell us how accurate they think the guess was. And it's identical is gonna be your true or false, okay? So pretty much the initial detection it uses also face detection because it needs to detect the faces, right? So we are using the Viola Jones object detection framework, right? That is provided by the cognitive services through through the Azure Face API, okay? Once that we have the cropped detected faces, we're gonna apply the eigenface framework, right? And then we're gonna project the detected faces into an eigenvector. And then we're gonna compare the eigenvector with the precompiled database of eigenfaces, and we're gonna have the closest match, right? And that's gonna return yes or no, true or false, right? So that's pretty much what we will need to do. So in a high level overview, right? I'm gonna go to the next slide. We're gonna check. I'm gonna show you, I'm gonna do a demo right now, but pretty much we're gonna go through the process of detecting the face and then verifying if the face belongs to the same person, right? That's gonna return yes or no. So after the face detection process, it comes the projection process, which complements the face detection algorithm by using the eigenface recognition algorithm. The algorithm's main purpose is to reduce the set of database images into a basis of eigenfaces. This set of images can be combined to recreate an image of a human face. Even after cropping a detected face, there is a lot of information in that face that we don't need, right? We only need a set of features for that specific face, right? The eigenface recognition model is used for these purposes. The operation that recreates all the eigenfaces is the principal component analysis, and it takes place in the projection phase. This is the same criteria that is used in the Microsoft Cognitive Service instance for the Face Azure API, okay? So let me show you, let me make a demo of that as well. So in the application, we went to the detection process. Now we're gonna go to the verification process. I already preloaded these with 2 URLs. I'm gonna click load images. We have the Amazon CEO and Google CEO. I click load faces, and I'm gonna click verify. And it's gonna tell me they are identical, false. And the confidence is pretty high. Now, let's see, I already have preloaded images from this as well. Let me click load faces, and now it's the same person. It should be yes. If I click verify faces, now the response is true and the confidence is really high. So this is the same person. We have verified that the two persons are the same, right? Now we can do the same with any other URL. Let's grab again Marisa, copy image address. Let's grab another picture from her. Maybe this one, which has another expression on her face. Load faces, let's verify, and they are identical, and the confidence is 0.7, which is fairly high. So we can verify that two people belong, well, two pictures belong to the same person, it's the same person. Now, the next step is identification. For verification, we take a biometric sample of an identity, in this case an image, and we look for the corresponding template of that given identity for that given picture, and to see if there is a match. So the system, the application is going to return true or false, right? For identification purposes, it's different. The system compares the sample to all the templates in the system, and the identity of the best matching template is returned from the system. So in this case, we first went through the process of detecting a face. Then we went to the process of verifying a face. And now we're gonna go through the process of verifying all the faces here belong to that person, all right? So I'm gonna show you how that works. I have here a selfie, one of the most famous selfies, and I'm gonna click analyze, and it's gonna detect all the faces, right? All the faces we have here. Now, this is how this works, right? The application itself allows you to store a group face ID. A group face ID is a group of people, and that group of people contains face IDs. The face IDs are the face that have been detected on that specific picture, okay? Which is the case right now. Now, as we saw before, when we got a detection, we got a face ID. So the only thing that we need to do in this case is grab the face ID that we have and try to find that face ID in the face ID that we have for the group, right? So we have a group, and inside that group, we have also face IDs. So we need to do a loop and find the face ID, and we will have a face identification, right? The one that has the higher threshold of, of confidence, or a given threshold, is going to be returned to us, right? So that's pretty trivial to do and simple. I just wanted to show you how does the process work, right? So this is really neat because it allows us to save this whole group of people, store as raw information of all the attributes that have been identified for this face ID. For example, for this person. Let's see. F1. Okay, this person. This person, we're not saving the image itself, we're saving all the attributes and the face that belongs to that image, right? So we have, it's smiling, yes. It has reading glasses, yes. What else? It's a male and he's 29. So that's pretty neat because we're saving all that raw information through the cognitive services, and it's available to us, right? This is a trial version, so I have certain amount of time and requests that I can store. So if you're going to be testing that, please don't run out all my resources. But go ahead, please do the test. I can always create another instance. And let's say, for example, 37. Let's see if I find that face ID, 37, right here. So face attributes, I see that she has 24, she's a female, she has no glasses, makeup is true, and we can check that. which is really neat. Now, the only thing that we can do, for example, if Marisa Meyer, like the face that we detected before, right here, we can check if that face is in this picture, and it will return yes or no based on all these attributes. So far we check detection, verification, and identification of a face. Okay, this is really neat. And also, while I was developing this, I went through one of our recording sessions and I did a screenshot of the gallery view of the meeting, and I put that page, and when I click analyze, all the faces are going to be detected. So let's check, Professor, some of the key features of you, the face that was detected. So this is safe in a group ID. This is your face ID. And let's see, for example, face attributes. So let's see if you're happy. No, if you're happy, emotion. You're not happy, you have a neutral expression. Facial hair, you have mustache, beard, and hair burns, which is over 0.5, which is high. There's a high confidence that you have facial hair. So that's pretty neat. And as you see, we can detect it as many faces here as we saw. It's pretty accurate. For some lighting, there's lighting scenarios where, maybe the face is not going to be detected. But other than that, it's pretty neat. Same thing, attribute and raw view is detected. JPEG. Here I have some other examples. And a close up of the picture with all the analysis. Okay, that's face identification. And let me go back to the slides. In the face group detection, as we saw, we list all the faces in a large face list and an image and retrieve in an image and retrieve face information. And then we extract all the attributes like gender, age, and emotions from all the persons detected in the image, like we saw. And as we saw in the demo, we have the information that was returned. And this is the example, the second example that we saw. And now we're gonna do a comparison of how efficient is the cognitive services from Azure, right? So for that, to fulfill that, we need to create analysis for TPR and FPR, true post rate, true positive rate, and the false negative rate. Okay, so we're gonna create a completion matrix and an analysis gender emotion. Now, we're using for these purposes one dataset. Okay, the dataset is the dataset of SOF dataset. Okay, it's available online, free, and it has images from different people. There was a huge challenge there because I had to upload all the dataset to Azure, right? And if you check here, I have to find a way to make this work. So this is the real information, right? So I have all these images from the dataset, right? It's huge. And from this dataset, I have all these attributes. I have the name, I have the index, I would call it. Then you have the gender, male, the age, 31, and then you have all other attributes, lining, for example, if the person is happy, if it is using, you have different attributes here. And we have the same person, with different, when they were taking the pictures, they have different lightings. So you can see let me show you. sees the same person but with different lighting conditions. So I have here the actual data. Now, what I need to do is, I have the actual data. The same way that we send that in a picture to be analyzed, I'm gonna do the same thing. I'm gonna send this picture that is uploaded in Azure to be analyzed by our cognitive service API. We're going to return that information because we have all those attributes. So I'm returning only gender and the emotion happiness to check how well cognitive services from Azure did, right? Based on the pictures that I have on this data set, right? So what I'm gonna do is I have a regular analysis or I have a random analysis, okay? A regular analysis is gonna go through all the data sets. Here I have, a tunable parameter, okay? I can here put 5, 10, 15, 100, or all of them. Now, there is a constraint. Because this is a free version, it usually takes 2 seconds. I put a timer here to make a request every 2 seconds. Because if I do it, if I don't put that delay, it's gonna do the request in less than 1 second. And if I do that, then I'm gonna get an error because there is a constraint where you cannot make, you can make only up to certain number of requests per second. And then you're gonna start getting like some errors. But that's one of the constraints when you have this free version of this instance of the service. Now, for demo purposes, I already went through the whole process, right? And I put 100, and from the 100, you can do a regular analysis. It's gonna go one by one in order, alphabetical order, or you can do a random analysis. From all the data set, it's gonna pick 100 items, and it's gonna do the analysis. It's gonna send those, and then you're gonna return all the attributes, and then you're gonna do some comparison, and then from that, you're gonna get the true positive rate for emotion gender, and you're gonna get the false positive rate for emotion gender. Same thing is gonna happen for emotion, happiness. If the person is happy, you're gonna get the true positive rate for emotion happy and false positive rate for emotion happy. If you see, this is not that high, right? For gender, yeah, it's okay. I'm also taking in consideration the faces that were not recognized. Let's say, for example, one where it differs, right? So for this specific example, we have here that the original value for emotion is no, but it was predicted as yes. So let's take a look to, if I click, I made it. So if you click to that picture, you can see it. Well, for me, it looks happy. Even though it says no here, it was predicted that it's happy. And for me, it's happy. I mean, it's interesting. Yeah, it's interesting. I mean, the Azure, the application predicted all this really well, but I don't know what happened here, why the actual says no. But you can go through all the samples that we got here. We can even here show 100. Let's see one that, they are no. It's no happy. Yep, it's not happy. Male 24, around 27. So it's pretty close. But in this case, I'm just analyzing the gender and I'm analyzing the emotion happiness to see how well, based on that data set, and how accurate is our application. So let me show you that. I did this 100. It took some time for me, but let me show you how could you do it for, let's say 10. Okay, I will click random. I will wait because it's doing all the process in the backend. Let's wait for that to be completed. So yeah, let's wait for that to be completed. And while we do that, you know, these are the two measures that we use, the gender and emotion. We have here the actual count, the predicted count, the true positive gender, the true negative gender, false positive, false negative, and then we calculated the TPR and the FPR for gender. For emotion happiness, we did the same thing. We count happy, the predicted, the true positive happy, the true negative happy, the false positive happy, the false negative happy, and then we calculated that. It finished. We only have 10, not 100 like I did that previously. But here we can check it random items. Let's say, for example, this person. Yeah, it says here that it's not as smiling, but we notice that it is happy. So that's different. And it kind of looked like she's smiling. So maybe our application is really, really good at analyzing all this type of stuff. So here we can show the analysis with each changes, right? It's completely different based on the number of items. So we have parameters that we can use to tune up this information and the accuracy that we're getting, right? Even if we train it more or we provide more information, we have more items, then this information is going to change. And so that's how we have changed all that. As I mentioned, this is all available. We have to tweak all this data to have it like this, so it matches. So it helps in the process of our research and for the purposes of developing this application. So we can compare it, how well does our application works. And that's in relation with that. This is the data set that we are using. Is available. If you have any questions, please email me. This is my phone. Before I close this, I wanted to tell you about the impact of this application, or at least for me, right? How will this help me, or how this can be applied in the future, right? So this application is just not using some service, it's creating a whole application from scratch, combining different development techniques to get all this information and applying all different functions of the code to reach or to fulfill the different features that we have showcased, right? So at work, we have this requirement in our team, a small team, that they want to have, they want to know if a person was present in a specific meeting. We're using Microsoft Teams for this. So we can create an add-in for Teams based on the application that I showed, right? And it would be pretty much what I've used, what I've showcased, where pretty much is gonna be an add-in, and I'm gonna use the code that I have. And what I'm gonna do is, once that everybody is on the Teams meeting, same thing that we have in our class, our live class, where we have the gallery view. It's gonna take a screenshot maybe every 10 minutes, or depending on the duration of the meeting. And then once that we have the screenshot, it's gonna detect all the faces, and then it's gonna verify each face based on the Active Directory information that we have on file. So we have a picture every person has a badge, and that badge they have the picture, and that information is saved in Active Directory. So we're gonna do a match verification, and it's gonna be pretty straightforward. So we're gonna use face detection, and then we're gonna do a face verification for all the people that have been detected on that, on that meeting. And if the person is found, then it's gonna pretty much mark as the person attended the meeting. And then, that will be pretty much, the base of how we can use this in real life. And that's one of the problems that I'm planning to solve right now. One of the requests that we had from a team manager that I have. So I'm gonna use this code and apply it to that project. Later on, I'm gonna tell you how it went. Hopefully, I will try to post this also online. After I finish the paper, I will post the paper, and I will post also the application. For features, I was telling you, I was planning to do the celebrity matching, but then I found out about this project, so I'm gonna replace that with the project, the attendance feature that I could have, and a video face detection, which is pretty much the same thing but through video. Hopefully I'm gonna start working on that in the future, and I can have that published online, and it could be used for. I will share the code in GitHub. Yeah, that's pretty much it. You have please any questions? Thank you very much.